children. Let us study about the method of preparation and properties of chlorine. Chlorine is the second element in group 17. This element was discovered by the scientist Cbse, but the name chlorine was given by Davy. Davy has given this name chlorine since in Greek the word chloros means greenish yellow color, and chlorine also possesses the same color, so that is why the name was suggested by Davy. So let us consider the method of preparation of chlorine. It can be prepared by the action of different reagents, like if you consider MnO2 reacts with HCl and produces MnCl2 plus H2O plus Cl2, or we can say that NaCl reacts with MnO2 and H2SO4 results in the formation of NaHSO4 plus MnCl2 plus H2O plus Cl2, okay, or KMnO4 plus HCl will give you KCl plus MnCl2 plus H2O plus Cl2. In addition to this, it can also be prepared by Decon's method, that is HCl on reaction with oxygen in presence of copper chloride and produces H2O and Cl2, or it can also be produced by the electrolysis of brine solution where chlorine will be produced at anode. Is it clear, children? These are the different methods for the preparation of chlorine. If you consider properties, chlorine is a greenish yellow colored gas and it is almost 2 to 5 times heavier than air. Okay, it is a greenish yellow colored gas with a pungent suffocating odor. It possesses a pungent suffocating odor and it is highly soluble in water and gives a greenish yellow color, yellowish green color solution. Chlorine reacts with almost all the substances. For example, if you consider sodium reacts with chlorine, produces sodium chloride. Aluminium reacts with it, produces aluminium chloride. Fe reacts with chlorine, produces ferric chloride, FeCl3. Or we can say that phosphorus reacts with chlorine, produces PCl5. Or sulfur reacts with chlorine and produces sulfur monochloride. Is it clear? Here you can see that chlorine reacts with both metals as well as non-metals. Chlorine has a great affinity for hydrogen. So it reacts with hydrogen and produces hydrogen chloride. Or if you just consider hydrogen sulfide plus chlorine will give you HCl plus sulfur. Or cyclodecyne, that is C10H16 plus Cl2 will give you HCl plus carbon. This three reaction shows that it has a strong affinity for hydrogen. In addition to this, chlorine reacts with ammonia also. If chlorine reacts with excess of ammonia, reacts with chlorine, you will get NH4Cl plus N2. But if ammonia reacts with excess of chlorine, then the product will be NCl3 and HCl. Is it clear, children? These reactions are important. That is, ammonia reacts with excess of ammonia reacts with the chlorine and produces NH4Cl and N2. But ammonia reacts with excess of chlorine and will give you NCl3 and HCl. At the same time, we can see that cold dilute solution of NaOH reacts with chlorine and produces NaCl plus NaOCl plus H2O. Or if hot concentrated solution of sodium hydroxide reacts with chlorine, then it produces NaCl plus NaClO3 plus H2O. Is it clear, children? Sodium hydroxide, when it is in the cold diluted form, it produces NaCl plus NaOCl plus H2O. But if it is hot concentrated, you will get NaCl, NaClO3 and H2O. Similarly, if you are passing chlorine through calcium hydroxide, you will be getting bleaching powder. That is, its composition is CaCl2 plus CaOCl the whole twice plus H2O. This is what is termed as bleaching powder. In addition to this, chlorine reacts with hydrocarbons also. Suppose if it is saturated hydrocarbon, it undergoes substitution reaction, and with unsaturated, it undergoes addition reaction. That is, if you consider CH4 plus Cl2 will give you CH3Cl in presence of ultraviolet radiation, and if it is CH2 double bond CH2 plus Cl2 will give you CH2Cl single bond CH2 Cl. So in the first case you can see the presence of substitution reaction, and in second case it is addition reaction. Chlorine, if it stands, if you are passing chlorine through water, it stands, yellow in color. It loses its yellow color due to the decomposition of chlorine water to HCl and HOCl. That is, chlorine reacts with water. It loses its yellow color on standing. It is due to the formation of actually HCl plus HOCl. This HOCl further decomposes and you will get HCl and nascent oxygen. This nascent oxygen is responsible for its oxidizing nature. Chlorine generally oxidizes by oxidation, so it is a permanent oxidation process. Let us see some examples for oxidation process. That is, ferrous sulfate undergoes reaction with chlorine and it gets converted to ferric sulfate. You will get Fe2SO4 thrice plus HCl. Or if you consider sodium sulfite Na2SO3 reacts with chlorine and produces sodium sulfate Na2SO4 plus HCl. Or if it is SO2 reacts with chlorine, then you will be getting H2SO4 plus HCl. Or iodine I2 reacts with chlorine and produces HiO3 plus HCl. Is it clear, children? That is about the general chemical properties of chlorine. If you consider uses, we can say that chlorine is generally used for bleaching. It can be used for bleaching textiles, wood pulp, cotton, etc. Chlorine can be used for the preparation of many organic compounds like chloroform, DDT, etc. It is used for sterilizing water. In addition to this, it can be asked, name two poisonous compounds produced from chlorine. Chlorine can be used for the production of phosgene, that is COCl2, or it can be used for the production of tear gas, that is CCl3NO2, or used for the production of mustard gas, that is Cl, CH2, CH2S, CH2, CH2, Cl. These are all poisonous compounds produced from chlorine. Is it clear, children? That is about the uses of chlorine. Now the next compound we have to study about hydrogen chloride, that we will do in next class. Thank you.